So here we have the biggest project I've done so far, which is the Antonus 2600 original size. This is a full recreation of the original ARP 2600 from the 70s. It also was a full DIY kit, which means you have to build it yourself. There's another video on this channel which shows a full time lapse of me soldering all the printed circuit boards of this synthesizer. So if you're interested in that, I will link it down in the comments or in the description. Now this is a very long video because I want to show the full experience building this synth. So I added different chapters below the video and in the description, so you can skip around or jump to another part of the video. So let's get to it. So these are the speakers that came with the kit. I accidentally ordered them also myself. So maybe I have to build another 2600. So these will have to be soldered to some bare wires with a connector to the boards. But I'm gonna do that later on. So I'll just position them right over now. And I'll just screw them in. I hope. Just to be clear, these screws were also in the kit, in the bag labeled speakers, so it's all very neat. I like it. So, that's all screwed up. Nice. Next thing we're gonna do is to put in this power supply board, which runs off the mains. And these are Meanwell power supplies. They are 24 volts, but we're gonna set them actually to 20 volts because that's more than enough to run the regulator board, which actually makes the plus and minus 15 volts. So Tony from Antonus told me just set them at 20 volts because these regulators over here will generate less heat, and less heat in electronics is always a good thing. So I'm gonna connect this one, gonna put the camera a little closer, and we'll go from there. But first, because there's a power switch right over there, which is this one, I'm gonna put that in the front panel first, so I can operate it safely, because we are working with main voltages here. Remember, this is all at your own risk, so just be careful. And I'm just a bit worried if I just leave it hanging over there and I want to operate it, I'm actually going to touch those contacts, and I don't want to do that, so it will go right over there. So it has to go like that. Let's get my screws. So I'm using the black ones that came in the kit. Those are for the front panel. Also for the boards, the standoffs. So let's put this power switch in. So that's the first part on the front panel. Start somewhere. So if you want to check again, I don't, but I'm gonna show you anyway. that's on and that's off. So that's good. Here's the mains in, which is this cable right here. So that will go, let's put it flat right here. AC in. And now we get our switch, which I check is off. And that one goes right there. So before we connect this to the regulator board, we're gonna set the mean wells to the, well, as low as they go, really, which I think is around 20 volts, but we're gonna measure that. So here we have the mean well board, and we're going to set those trimmers to the lowest values. And you can do that without the meter, but I'm just wanted to show you how low they will go. I'm just gonna tape this wire so I can measure it more easily. I could measure on those points, but then my hands will be in the way. So I'm gonna flip the power switch. Now it's on. So first we're gonna look at the plus rail, like that. And we're just gonna set this to 20 volts, or the lowest value. Let's see how low they'll go. Oh, 20.8. Let's make it 20.5. Because that's a nicer number. So now we're gonna check the other side, or the minus rail, which is this one. Ah, that's a shame. Bastard. Well, there you have it. 20.52. Unplug the power cable just to be sure. And that's those mean well boards or supplies done. Now we can plug this in the regulator board. But first, because we're done with this one, I'm gonna screw that up. Or screw it in, not screw it up. That would be a shame. Oh, almost forgot these nice covers to cover up the contacts. Okay, the contacts. I'm sorry, English not my latest language. Right there. So you'll need these. Also come in the kit. Everything comes in the kit. All the screws, or at least I ordered all the screws in the kit, as well as all the hard to get parts or a bit rare parts or whatever. And I ordered the rest myself. So let's put those spacers in first. And there you have it. So we have to tidy up those cables, but I'm gonna do that as a very last step. So let's move on to the regulator board. So the regulator board, we can just screw in first, because test points are on top and the trimmers are right there, so it's all accessible. So we can just put it right there. Now we take the main cable from the mean well supply and just plug it in over here. This is the input right there. So I'm going to power it on and hope there's no smoke. Meanwhile, all powered, but no lights. Turn it off. No lights on the regulator board. So let's check if we have a voltage. So these are the things that can happen when you're DIYing. So let's just take a supply and see if there is 15 volts on there. And there is. Let's check the other side. Plus 15 volts, so that's okay. So the regulator board's fine. I think I've put the LEDs in the wrong way. Yeah, so let me correct that and I'll get back to you. I replaced the diodes or LEDs. Yeah, they are diodes, but whatever. They were in backwards. So yeah, noob. Let's flip the switch. As you can see, they're all glowing now. And let's set the plus and minus rail. This is the minus rail, this is the plus rail. Let me zoom in a little bit. So we'll start with the minus rail, 15.3. So it has to be 15 because we can. Awesome. So let's check the plus rail. 15.3, this one. Oop, wrong way. $15 volts. Check the other one again. Hello. Yes, minus 15. And here we have plus 15. So let's turn it off. So that's the Meanwhile board and regulator board. So the whole power supply of the synth is now ready to go. I love building this thing. So before we put power on any of the boards or test them or whatever, I just wanted to go through what all of the boards are. So here, for example, we have board A. This is board B, C. So this one goes on the left side, this one on the right side, and the C board goes on the bottom. Let me flip them over so you can see all of my beautiful soldering. That was a lot of work, but I love it. I'm almost a bit sad that they're all done, because I can just keep soldering these kind of boards all day long. I love it. This is the left-hand side board, which contains all of your VCOs. So all those little building blocks are your VCOs. This is your ring modulator board. This is the Antonus MIDI board. So yeah, there's also a preamp on here, an envelope follower, and you've got your LED driver. So on board B, which is of course this side, you've got your VCA, your envelope or ADSR, and your filter. You've also got your mixer on here. This circuit goes to the jack outputs. You've got your reverb circuit, and I think that's about it. But there's so much on here, I'm bound to forget something. So, port C, which is the bottom one. This area. This contains your sample and hold circuit. And this is a tiny little board, this is your noise generator. You've got a voltage processor on here, your electronic switch, etc., etc. On both ends there's a TDA chip which is your amplifier circuit for the speakers. So yeah. So next step, get one board, put power on it, hope the smoke stays in it, and test them all. And then we can assemble the front panel. Got my scope ready and my little function generator. We're now ready to test all the boards. I've put the front panel like this so I can still operate the power switch. But before we connect any of these boards to power, we're going to check for shorts. I'm going to show you how to do that. So first, make sure you disconnect power to the case. I'm going to test for shorts on these points. I'm going to show you how to do that. But first, to set an example, I've got this little cable here, which I shorted 2 pins with a little bridge, so I can show you how to measure for shorts. So let me put the camera down and I'll get back to the regulator board. I'm going to show you how to measure the boards for shorts. So with nothing connected, we set the meter to resistance or the ohm settings, and we're going to measure on ground and the plus rail. Remember, without any power, it's completely turned off. So 2.6K. Let's measure the 2.5. So that's the baseline. So if there's a short, you will see a 0 reading. So there's a short on one on the rails because the center wire is ground. So we've got a ground and a minus and a plus 15 volts on either side. So no power on the board. Let's plug it in with the short. And let's measure the rails again. So now we should see a short on one of the rails. So the plus side is fine. So there should be a short. You see, there's a short on the minus side. And if I unplug that bridge and measure again, the short is gone. So it's just an easy way to explain how to measure this stuff. So we're going to start with board B and I'll show you how to measure that. So now we're looking at board B, which is the right hand side of the synthesizer. This is where the power comes in from the regulator board. So I'm just going to plug this cable, which has 2 connectors. One is going to board B and this is for the speaker circuit on board C, but we're not going to use that now. Let's plug that in. No power. It's completely turned off. And let's get that connector into board B. Now, I could measure on these points right here where the power comes in, but to make it as easy as possible, I'm going to measure every time for shorts in the resistance setting on the regulator board. So plus, there's no short, and the minus rail, no short. So there were no shorts on the power cable. I'm going to show you, if we take that bridge from this connector and remember there's no power on here. If I just short a rail on one of these boards, so now I'm shorting the minus rail to ground, we should see that when we measure at the regulator board. So let's do that. So the plus rail is still fine, no short. And the minus rail, we can see on the meter, there's a short. So that's a good example on measurements. So now we can power the board and see if we have both rails plus and minus 15 volts on all the boards. Make sure the switch is turned off. Let's plug in some power. And turn it on. All lights are fine on the regulator boards. So there is power going to this board now. Now don't be scared if there are no LEDs lighting up from the sliders, because those are connected to board A, which has the driver circuit on it, and that's connected by ground. I think by connecting these interlock cables or interconnect cables or whatever. So that's why they don't light up. So I'm gonna check on these boards. There is a plus and minus and a ground on the silk screen, so we can measure if we have a voltage on those to check if there's power going to the boards. Let's check those voltages. Negative side, minus 15, beautiful. Plus side, minus 15. Next one, ground, minus and plus. Nice. And last one, ground, minus 15 and plus 15. So this board, let me turn off the power here. This board is ready to go. So let's get on to the next board. Next up is board C, which is the board on the bottom row of the synth. Let's unplug the power. And on the same connector, so remember this one went to board B. So we're not going to use that. We're actually going to use the purple one, purple black. So that goes to the speaker circuits or the TDA amplifier circuits. So this comes straight off the mean well, so there will be 20.5 volts on there. So let's check that first. No shorts. Let's unplug the power and take one of the VCO cables or VCO power cables to check this. So from the regulator board to the power in. And let's first check the resistance to make sure there's no short. So plus rail, no short, minus rail, no short. So let's plug in the power and turn it on. All lights working on the regulator board, no funky stuff. And let's set this in voltage mode. First we'll check the noise generator. Plus 15, minus 15, it's all good. And the sample and hold circuit, minus and plus. So that's it for board C. Let's get on with board A, which contains the VCOs and the ring modulator and the MIDI board. So let's first check the ring modulator, which gets power from this connector. No power. Let's plug in that connector from the regulator board first, and then we're going to check each of the VCO power rails for shorts. Minus rail, no shorts. Plus rail, no short. Next one is VCO number 1. Let's check for shorts. No short. plus rail. All good. Next one, VCO number 2. Same thing. Very boring, but I'm going to show everything. Nope. And that's a no. Last one, before we put power on them. It's good. So, let me just reset the camera and we'll flip the switch and rock and roll. So, with a cable in one of the rails, plus and minus 15, we're going to check all the different points on this board. So let's flip the switch for VCO number 3. Check the voltages. Minus 15. Plus 15. Beautiful. So turn off the power. Let's wait for it to die down. Yeah, it's enough. Unplug it and plug in the next one. And let's check those voltages. Yes. Yes. Next one, which is VCO number 1. Turn it on. 15. Minus 15. Beautiful. Turn it off. So, last one. Turn it on. Ground. Minus 15. Plus 15. Minus 15. And 15 volts, yes. So, it's all working. Turn it off. So, now that we checked for shorts and checked if all the different parts where the power comes in actually have a voltage, which they do. So that means we can assemble the front panel. I'm gonna start with the little things, like this multiple board, which goes on the left hand side, the power light, which goes over there, and the headphone socket on the bottom right there. After that, we're gonna put in port C, which goes on the bottom. So that will go, whoop, flip it over, right there. So let's do that. Let's assemble the multiple board, which also contains the CV output, which comes from the side of the case. Looking good. So there's your multiple board. So let's put in this headphone socket, which came already wired in the kit, because I ordered the full cable kit. So that doesn't fit. So I think we actually have to drill this panel to fit the headphone jack. So let's do that. So I've got my little trusty step drill over here. I don't like this, but I have to. So bear with me. There we go. Gonna take away the burrs later on. That's nice. So that's the headphone socket. Let's move on to the power LED. There's a connector with this for the board, but that doesn't fit inside the hole. So first you have to put it in with the bare connectors. That's a really tight fit, but it should be, because it clicks in. So now we have that. Beautiful. Just to show you how to connect the power LED. So you've got two wires. There's an R for red on the connector, and it goes in like that. Till you hear a click, click, and then the white one. And that's your connector. We're just going to let that... Now I'm going to put in board C. Just be careful and check that you lined up all the sliders so they don't break off. Let's see. Let's put in the screws for the standoffs. Let me zoom in just a little bit. And there we have the first board in. Nice. Looks good. Next one. So that's board A. A little bit hard to get in, but I've managed. So next up will be board B, which I have right here. So just feel around till you feel the sliders dropping through the front, like that. Now we lift up the panel to see if we can push it through, which is the hard part. I've got the board in, And the reason why it was so hard to get this one in is because the board was a bit warped. So it was like that, which really F's up the mounting. But it's in now, so let's screw it all in place. So there we are. All the panels are in. Looks absolutely beautiful. Of course, all the knobs have to go on, but I'm gonna do that as a last step. This is how it looks like. Step is to connect all the cables, which I've got right here in my trusty little box. It's box O cables, like that one. So there's a lot of them. So we will lay down the front panel and I'll show you how to connect them all. So, first thing I'm gonna do is connect the loose cables already in the case. And then I'm gonna solder these first. Those are the speaker connectors, which have to be soldered to the speakers themselves. So that's the first step. I've got this little list, which you can download from the website from Antonus. And this shows you every cable and where it's connected. We'll start with the easy ones already on the board. So this is the light, power light, which goes right in the connector next to it, like that. And then we got this headphone socket, which goes into this one on board C. Now, it's a little short for my taste, but it's just barely long enough, but it works. So maybe that will be longer in the future kits, or not, I don't know. Tony. Next one is the reverb connector. That one goes right here. It says reverb on the board. So, yeah. And next is the output jacks over here. Then we go to the other side, where we have connectors for the MIDI jacks. And those, of course, go into this MIDI board. That one is over there. Like so. Let's solder the speaker wires first. So this is the plus side. This is the minus side. And we got these little cables. Let's solder them on. And plug them in. Other side. Plus and minus. get another cable. First tin those wires. And solder them in place. Next one on the list are the main supply cables. So J5, which is on the regulator board, to 46, which is port C, and 55, which is port P. So that's this one. It's like a little splitter cable. This one goes on the regulator board. And then we got one for the speaker power. And one for this one. So that's that. Next one goes from the MIDI board to the MIDI panel, which is this cable. So let's first connect it to the panel on the side here. And this goes in the MIDI board. Like nya. Next, the external CV gate cable, which also goes to the same board. To this connector right here. Next up are the VCO cables, which go from the regulator board to these points, and also a little shorter cable to the ring modulator, which is this connector, and that's powered from this connector. This is the power cable for the ring modulator, which is a little bit shorter. And that comes from J2, which is this one, to the power in connector of the ring modulator, which is this one. Nice. Next up, the cable for the multiple, which is this little board right here. And that comes from this connector. So it's a little 2-pin connector. And let's plug that in. Like so. So now we've got all these interconnect cables, which connect all the boards together. So we've got J15 to 16, which are these connectors right here. And then we've got 18 to 17, which is this one to this one, and 19 to 14. So pretty straightforward. So last one is power for board C, which comes from this connector. So remember, we've only had this one, which is power for just the amplifier circuits for the speakers. And the rest is powered from this cable, which is coming from the regulator board, of course. And those go straight through to these connectors. So this is also a plus and minus 15 volts, which plugs directly into port C. So there we go. Now, before I'm going to do any cable management, I'm first going to power this up, which is the scary part always, of course. And if all is good, we're going to tidy this up. So all the cables are in. I've got a little sequence going to the MIDI input. And I'm gonna flip the switch and hope it fires up. So let me just check. There's nothing shorting out over here. I'm gonna lay down the mic at one of the speakers and rock and roll. No smoke. So that seems to work. Very happy. I'm going to check all the functions, and the next one will be a full calibration of the machine. So bear with me. So I've done some cable management, or at least tried to. I think it's fine. So before we mount the panel into the case, we have to adjust all of these trimmers beforehand, and then we can mount it. There are also many trimmers on the other side which you can access through the front panel, but we have to do these first and then we can move on. So first thing we are going to do is to set the internal clock. To do that, we have to monitor this internal clock output, and I'm going to use these nice little adapters or wire taps from Free Tom Modular. Thanks, Tom. So I can connect this mini jack cable to the internal clock. Nice. So now I have to figure out how I'm going to hold the panel while adjusting the trimmers, which are down there. So just hold on a minute. I've got another cable, so I can put the front flat on the table for trimming. I've got it connected to the scope. Now the goal is here, as I increase the rate of the sample and hold. Now you see it disappears on a higher setting, so we need to adjust the speed or init trimmer so it doesn't disappear at max rating. After that, we're going to change the width for a 50-50 duty cycle, which is not like this. So let's put the panel flat on the table and I'll show you how to adjust that. Here we are. First, we need to get that signal back. So we adjust the speed. Let's turn this until the signal comes back. There it is. Just set it for maximum rating, like that, with no wobbles. Now we have to adjust the width for a 50-50 duty cycle. That's this one. It says so width on the board. Let's adjust that so it's an even square. We can measure that. So we have this duty cycle. This has to be 50%. Then it's even. So that's the first part done. For the next part we're going to monitor the triangle output for VCO2. So I've got my cable plugged into the triangle output. Looking at the scope, you can see the peak of this triangle is not really symmetrical, so we have to adjust that. And to do that, we need to adjust R115 for the best triangle waveform. So the trimmer for the triangle symmetry is this one, 115. So let's turn that one until we get a perfect triangle. Looks like a triangle to me. Next up is the offset of the triangle wave. That's this one. We need to set that so the triangle is perfectly centered. So the minimum and the maximum have to be the same. So let's turn that pot and adjust that. Almost there. Looks good to me. Next up is the level. And we're looking for a 10 volt peak to peak output. The level trimmer is right over here. And we're currently at a 15.2 volt, 15.4 volts peak to peak. So let me turn the pot till we get a 10 volt peak to peak. Oop, too far. That's nice. Notice we're in the sine output jack, but we're getting a triangle. So we have to adjust the round setting, round trimmer, which is this one. So we get a perfect sine. But to be able to do that, we might have to change the gain or the level up above the 10 volt peak to peak, but we're just gonna try it first. So let's see if we can get a sine. Oh, there we are. Now you can see we're already at 20 volts peak to peak. So let's dial that back. To 10 volts with the level control. Like that. And we're going back to the roundness. That's becoming a square now. And that's a triangle. So looks like a sine to me with a 10 volt peak to peak. Beautiful. Now we're going to adjust the scale of the MIDI controller. So I've got the duophonic MIDI interface in here, which is an option, It's that board. So I can play this in diaphonically. Now I also have a KeyStep Pro right over there. So I could just send 4 voices out, but I've got the MIDI, diaphonic MIDI board as well. So what we have to do, we need to monitor the direct voltage from the MIDI in, which is this one. And we need to compare that to the CV signal coming out of the MIDI board. And these, within the range from 0 to 5 volts, need to be not more than 2 millivolts apart. So that's the last digit. So I hope that's clear. I'm using my D50 for the MIDI signal. So we are at 0 volts. If I go an octave higher, that's 1 volt. So this is the reference. You can see that one is out already. 2 volts, 3 volts, 4 volts. And at 5 volts, that one is way off. So we can adjust that by trimming this pot right here, which is the CV scale trimmer. So I'm turning it now. So the right meter is exactly the same value, like that. So let's check the range again. 0 volts, 1 volt. Remember, this needs to be within 2 millivolts on that one. 2 volts, 3 volts, 4 volts. I would say that's spot on. So that's that. We've adjusted all these trimmers on the back, and I think you know what that means. We can now mount the front panel into the case, and then we can, or I'm gonna put on all the knobs, these beautiful caps that go on there, and then we can trim all of these pots on the front. So you'll need something like this, which is a pot trimmer. You can just stick it through the board and adjust the pot. Just to show you, this one is the LEDs. This one controls the intensity of the LEDs. So now it's brighter. You can turn them off if you want. Absolutely beautiful. Let's assemble this beast. So you want the top to go in first. Okay, and then you can slide it in. That's how it should be going. Like that. So this is the knob for the preamplifier. So we've got these beautiful knobs which shine through, so you can see the orange light if you want them. Let's see how this looks like with the LEDs powered on. This is the trimmer for the LED intensity. Look at that. I've got the same on my ARP aux over here, which I installed the same sliders, just different caps. Second part of the calibration, which are all of these front trimmers, these pages, which are from the service manual of the original ARP 2600. I've made these files so you know which trimmer does what. This is a layout of the front panel. I also made this one. Bad picture from the front, but all the names are there. These files will also be in the download file which you get from the Antonus website. So I'm using the D50 again for my MIDI. I'm gonna start with adjusting the volt per octave for each of the VCOs. I'm only gonna show you VCO 1 because they are all the same. So we need a 1 volt signal and a 5 volt signal. So I've got my 1 volt and I press the high C, I've got a 5 volt. So that's gonna work. Let's calibrate VCO 1 for a 1 volt per octave signal. We need to monitor the output with the scope or a frequency counter or whatever. I'm going to use the square. Doesn't really matter which one you use. So now we're going to set the slider to 100 Hertz with the coarse and the fine tune. So like that. So now we press the highest C on the original keyboard, ARP keyboard we don't have, so we just need a 5 volts. So we've got a 5 volt signal now. And this should be 1600 Hertz, and it's not. It's like 14, whatever. So we need to turn this pot. These top ones are the 1 volt per octave trimmers. So let's turn this one until we get 1600 Hertz. Or about, because you're not going to get it right the first time. So that's 1600. Let's get a 1 volt signal again for 100 Hertz. And set the sliders to get 100 Hertz again. Yeah, close enough. Now we get a 5 volt signal again. It's still not 1600. So let's turn the pot again. Almost there. Go back to 1 volt. You're not gonna hear this difference, but my OCD is kicking in, so 5 volts. 1600, almost. Oh. 1 volt. 1 volt, not volts. And we got 100. 5 volts. We got a 1600 almost. So that's as good as it's gonna get. So every octave is double the frequency. So if 1 volts is 100, 2 volts will be 2, and then 4, and then 8, and 1600. Beautiful. So that's VCO 1 perfectly tracking. Now I'm gonna do the other two, which are exactly the same. So I'll do those and then we'll calibrate the ring modulator. So I've done all the oscillators. Now I have been tweaking the ring modulator, the positive and negative nil, and I found out it sounds best with the trimmers in the middle position. But that's just how I like it, so don't know for sure if that's correct, but I'm gonna leave it like that. I'm just going to adjust the gain of the ring mod. So with both sliders up, we can see on the scope we are at 28 volts peak to peak. That has to be, let me just check, 20 volts max. So I'm going to adjust that pot, which is the bottom one, for a maximum of 20 volts peak to peak. Whoop, that's the wrong way. Yeah, close enough. So that's the gain of the ring mod. Next up is the pulse width adjustment for VCO 1. So we're monitoring the square output from VCO 1 and we are looking for a duty cycle of 50% because we don't have a pulse width slider on VCO 1, so we have to set this for a perfect pulse width or duty cycle, whatever you want to call it. So that's this one, this pot over here. Let's turn that for a 50-50 duty cycle. Oops, wee. Whoop, there we are. Now we can see here the square is not straight. So that's a little bit of a different character than VCO 2 pulse or 3. So that's perfectly straight. VCO 3 also. And number 1 is a little bit angled. So it's a different character from that one. I like it. Can't wait to make a sound demo with this one. Next up is the frequency calibration of all the VCOs. I'm just going to show you VCO 1. We're going to adjust the bottom trimmers on this one. So it says in the manual to put the slider at maximum rate or maximum frequency, and then it should be 8.33 kilohertz, and it's currently 4.44. So we're going to adjust that frequency to 8.33, which is hard. So get it as close as you can, like that. Now still, if I sort of fine tune it in the middle, if I put it at 1K, I'm not really getting 1K. No, it's close. But at 100 Hertz, I'm getting like almost 70. So the scale on this is not really what it's outputting. I wonder if it's the case on the original ARP 2600, but I can live with that. So I'm just gonna leave it. So I'm going to do the other two VCOs now, and I'll get back to you. Got to mention, you do need a dummy plug for this. So this is just a little mini jack, and you have to stick that in the keyboard CV when you're adjusting them. So by doing that, you disconnect the internal routing of the keyboard CV. So now it's free, so to speak. Now we're going to calibrate the frequency of the VCF. And we have to monitor that. So we take this output to the scope and put the frequency slider far left. This one mid-range, and put the resonance up so we get a sine. And currently it's reacting to the keyboard, so we have to disengage the keyboard CV. So we're going to get our dummy plug and plug it in keyboard CV. So now it's a free VCF. And we have to trim this pot, which is the frequency pot, to 10 Hertz. So now it's at 51. So let's set that, so max, let's set that to 10 Hertz. Nice. Next up, we're going to set the control rejection for the VCA, which is this trim pot right here. So I've set the VCO, you have to set the VCO into the low range, low frequency, and you have to set that to about 2 Hertz. I already did that. So we're going to take the sine output and we're going to plug that into the AR input or the linear VCA input. And we're going to look at the output of the VCA on the scope. So we're going to put this slider at the max. And we're seeing this 2 Hertz signal, which we don't want to see. So we're going to adjust that rejection pot for a minimum output. So let me just set this signal to the middle. I think we're there. So that's the control rejection of the VCA. Next thing we're gonna set is the high frequency rejection of the VCA, which is this trimmer. I'm going to connect the output of the VCA, because we're doing this by ear, to the input of the preamp. Set that to 1000. The output, don't forget to lower the gain. The output of the preamp goes into the pen pot or the pen input, so we're bypassing this mixer. VCO3 is set to a 1K signal, so we're going to raise VCO3 into the VCF. We're going to set the cutoff fully open. And now we're going to raise the VCF to the max. Turn on your speakers. Raise the gain. Now this is a very annoying sound. We're going to turn that high frequency rejection pot for a minimum signal. right about there. So let's turn that off because that's an annoying signal. So that's the high frequency rejection of the VCA. Now we're going to set the linear gain adjustment of the VCA, which is this trim pot. So I already set the filter to a 1K signal, so you get a nice 1K sine to test with. Now you can do this with a scope or on the speakers. I'm going to do it on the scope because that signal is very annoying to my ears, but let's hear how that sounds. So first we're going to patch the filter output to the input 1 of the inverter. The inverter output is going to the first mixer input, so we break the connection of the VCF. We're going to raise both of those and raise the VCF to the VCA and put the initial gain at a maximum. So now you can hear that signal, and we have to trim this pot for a minimum signal level, but that's very annoying. So I'm going to monitor the left output, and we can see a sign over here. I don't have to hear it. So now we're going to adjust the linear gain trimmer of the VCA for a minimum level. So that's the linear gain adjustment. Next up is the VCO tracking, the 1 volt per octave, which is this trimmer right here. At 0 volts, it should be 200 hertz. You set the sliders to 200 hertz, like that. And then we press 2 octaves up, or 3 octaves up for 3 volts. And then it should be 1600 hertz, which is not. So let's trim that pot. So we get 1600 hertz. And repeat, 0 volts. And let's set it to 200 hertz, like so. Go back to 3 volts. And adjust the trimmer for 1600 hertz. And you go back and forth like that until it's tracking nicely. Yeah, I think that's as close as I'm gonna get it. So now the VCF is perfectly tracking. Next up is the output offset of the VCF. So we're adjusting for DC offset, so this is offsetting too much. It should be in the middle. So the top one of the trimmers is the output offset. So we adjust that so that line is in the middle. Looks good to me. So last one, we're setting the gain of the filter, which is the bottom trimmer. So we are looking at VCO1 square, which is the blue line, and the VCF output of with VCO1 opened up on the mixer, which is the yellow line. You can see they're not the same, so we have to adjust that. Let's put them on top of each other. Now I'm going to turn the gain trimmer of the filter so they are both the same. like that. Beautiful. So this synth is now fully calibrated. So now we can cover up all of those trimmer holes. I've got these rubber caps which you can push in. So that's a nice finishing touch, so let's do that. So now all the trimmer holes are plugged up, so it looks a lot nicer. And there we have it. One beautiful 2600 fully built. I love it. I hope you enjoyed the video and I will see you in the next one. Maybe we'll build a beautiful matching sequencer for it. Tony, bye.
Thank you.